Berlin, the German capital, is a 21st century metropolis in the heart of Europe. It has a long history, famous historic buildings and unique architectural monuments from various eras through to contemporary architecture. All these modern buildings and projects consist of quality-controlled construction materials with selected characteristics, extreme resistance and high demands on environmental compatibility, on static equilibrium and structural safety. The company testing Bluhm and Feuerherdt is based in this European city. In its modern production facilities, Testing, one of the most renowned German providers of complete construction material testing laboratories, manufactures testing machines, premium laboratory devices, as well as stainless steel laboratory equipment of the highest quality. Our product portfolio contains around 3,500 different, mainly standardized products. For new and further developments, we have experienced mechanical engineers, electricians, hydraulic specialists and concrete experts at our disposal. Here, a new Blaine device is being developed in the engineering department. We currently produce the widest range of Blaine devices worldwide, from simple hand-operated devices to computer-controlled automatic models. The PC-controlled electronic Blaine device number 1.0297 is used exclusively to determine the grinding fineness of cement and should only be used for this purpose. To determine the grinding fineness of cement, its specific surface area must be established from the air permeability of an accurately defined compacted cement bed. This is done by observing the time taken for a fixed quantity of air to flow through the cement bed. This time is then a measure for the specific surface area, which is indicated in square centimetres per gram. The laboratory, testing equipment and test material must have a temperature of between 18 and 22 degrees Celsius, as well as a maximum relative humidity of 65%. Inspect the visible condition of a delivered consignment immediately. Any damage which occurred during transport or a shortfall in quantity must be logged without delay and submitted to us by fax or email. Use the delivery note to verify that the consignment is complete. It must include an electronic Blaine device, a permeability measuring cell with a perforated disc and plunger, a suction and filling syringe, a 50 ml bottle of manometer liquid with alternative filling funnel, a can of grease, a packet of filter papers, a plugging rod, a brush, a sealing plug, a PC connection cable, operating software, operating instructions, and an application DVD. Items not included in the delivery scope include different reference sands, a measuring spoon or spatula, an analytical balance accurate to 1,000th of a gram, a fine brush, a bottle with screw top, an electronic vernier caliper with depth gauge accurate to 100th of a millimeter, a PC with Windows 7, XP or similar operating system and a free serial interface, or alternatively a USB connection with serial interface adapter. Irrespective of the type, the Blaine device must first be set up and aligned on a stable, level and vibration-free surface. The device is now ready for operation. The manometer liquid has to be sucked in with the aid of the filling syringe. Remove the cell and insert the tube of the filling syringe into the U-tube and fill in the liquid up to the lowest etched line. The U-tube must be clean and dry before filling. The liquid must be filled in gradually as the gauge only adjusts very slowly. If the filling level is exceeded, excess manometer liquid must be carefully sucked out using the syringe. The etched lines on the U-tube are filling height, stopping point and end of the measuring section, starting point and beginning of the measuring section, suction level of the liquid gauge. The other components of the Blaine device are filler hole with protective cap, measuring section with photoelectric barriers, U-shaped tube, permeability measuring cell, connection support and control light. The power socket, serial interface and main switch are at the back. Determining the apparatus constant K. As the Blaine method is a comparative test between a known and an unknown material, a reference sample with a known specific surface area as a comparison is required in order to determine the apparatus constant K. As supplied by the manufacturer, the device is, as a rule, not calibrated. Calibration must be carried out in which the apparatus constant K is determined for the reference substances. This is required later in order to calculate the Blaine value. If the apparatus constants have already been determined, testing can begin immediately. Switch on the Blaine device with the main switch at the back. Use the interface cable to connect the PC and the Blaine device. Insert the supplied CD into the relevant drawer in the PC. Open a browser, for example Windows Explorer, to view the contents. We supply the software in 4 languages. Select the required language with a double click. Select the files from this CD drive. You can copy the files onto a desktop or a directory prepared by you for the program. Select the Blaine.exe file. The starting window of the Blaine software appears on the screen. Communication between the device and PC is configured under menu item Tools Interface. A new window opens. Select your interface and press the Accept button. Input of an incorrect interface will display an error. New search. The correct interface has been located and selected. Press the Accept button. Startup also includes entering test-relevant parameters. Open the menu item Tools Apparatus Settings. This opens a new window. Inside the Blaine device is a temperature sensor which measures the air temperature during the test. Press the Import button to see the current device value. If this deviates from an external reference thermometer, you can adjust it in the Offset field. If the device thermometer, for example, is 1 degree too high, enter an offset of -1. You can choose between EN and ASTM standard values. The starting time of the pump, as well as the pump capacity of 0 to 100%, can be individually adjusted. As a rule, this is a preset service function. In the Output Format field, the test result text can be displayed, stored and printed out in 2 versions. Enter the inner diameter of the cell and test bed height of the sample in the field Cell Data. If these data are not known, the permeability cell must be measured with a micrometer gauge accurate to 0.01 millimeters. The diameter of the cell is determined at 6 different points. The mean value is established and entered in the computer field. The perforated disc is placed on the lower edge of the measuring cell and pressed in with a tamper. 2 filter paper discs are inserted and pressed with the tamper up to the stop. Now, using the depth gauge, measure the inner dimensions J of the cell at 6 different points. The measurement should be accurate to 0.01 mm to give an average value. Also, measure and determine the length of plunger F at 6 points. Now, the powder bed height H can be mathematically determined. This is done according to the following equation. The test bed height, H, is calculated as the difference of the interior cell dimensions J minus plunger length F. The values of the cell diameter and bed height are calculated to 2 places behind the decimal point and entered into the PC field. In the execution field, enter the number of samples and number of tests performed for determining the apparatus constant. In each case, there are 3. Click on the menu item Tools, Manage Apparatus Constant. Here, the name of the reference substance, its porosity at 0.5, its density, as well as the specific surface area are adopted and entered. Users must set up all their reference substances for the later comparative measurement, for example, fine, medium and coarse. The values are adopted by the reference substance and entered in the corresponding field. The apparatus constant A is 0 since it is only now going to be determined. The constant B is not taken into account for this model. Now click on the menu item Tools, Calibrate Apparatus Constant in order to determine the various apparatus constants for the previously entered reference substances. From the already entered parameters, the computer calculates the sample weight. As a preparatory step, the selected test substance is shaken for at least 2 minutes in a bottle with a screw top in order to dissolve any agglomerates. The vessel is then left to stand for 2 minutes. Subsequently, the powder bed is stirred with a clean, dry rod in order to evenly distribute the fine particles. Lightly grease the tapered exterior of the permeability measuring cell in order to guarantee that the U-tube is airtight. The perforated disc is placed at the bottom of the cell and pressed flat with the tamper. A filter paper disc is laid on top and also pressed lightly. Then, the sample weight of the reference substance calculated by the computer is accurately weighed on the analytical balance to 0.001 grams. Different working tools can be used for this purpose. Enter the weighed quantity of powder in the field. The powder bed is leveled by lightly tapping the cell wall. A second filter paper is placed on the leveled surface area. In order to compact the power bed gently but firmly, press the plunger onto the bed so that the lower face is in contact with the upper edge of the cell. Then slowly raise the plunger approximately 5 mm, rotate it through 90 degrees and press it onto the powder bed again. The bed is now compacted. Slowly withdraw the plunger without disturbing the sample bed. Place the cell with a lightly greased exterior into the glass cone of the U-tube. Briefly press the Start button on the PC. The test will now run automatically. First, the manometer liquid is sucked in to above the upper light barrier, then the pump switches off. The liquid level gradually drops. The flow time and the temperature are recorded electronically. The time measurement between the light barriers begins as soon as the measuring section reaches the starting point. The sample material is run through. The measurement ends at the stopping point. Measuring time of sample 1. The first measurement is running. The flow time and the result of the apparatus constant K for the run is displayed. The second test run of the first sample follows immediately. The third measurement of the first sample is carried out including a temperature recording. After the third measurement, the measuring cell is removed from the glass cone and a second sample is prepared. This is then also tested 3 times. Finally, a third sample is prepared from the reference substance and also tested 3 times. The mean value from the 3 tests is calculated from the 3 measurements. The new apparatus constant K for the corresponding calibration substance can be stored by pressing Accept. The data can be saved before restarting. A window opens for queries. Finally, a querying for local file storage takes place for the results just determined. The content of the file is indicated by double-clicking. Via the menu item Tools, Manage Apparatus Constant, all apparatus constants can be seen. Here, as an example, reference substance 1. Calibration or recalibration is carried out for first use, after 1000 tests, for a different type of filter paper, for another type of manometer liquid, for new perforated discs, for a new manometer tube, and in case of systematic deviations of the secondary reference cement. The apparatus constant is not transferable to other devices, not even to the same models. Determining the specific surface area of cement. Procedure. Enter the freely selectable test parameters in the menu item Tools, Apparatus Settings. This is the number of cement samples in which the Blaine measurement should be carried out, 2 as a rule. The number of individual tests per powder bed is indicated in the repetition field, 2 as a rule. The break time between individual measurements is indicated in the pause field. The after run field refers to how high the fluid level is drawn in above the upper light barrier. First of all, check whether the cement to be tested is already stored in the database. This data can then be called up for a test. Any new data should be entered into the database. To do this, open menu item Tools, Manage Test Material. Here we can then enter a new type of cement with the name XYZ. All current types of cement can be managed by adding or removing. Density comes next. Then follows the porosity with which the cement bed should be made. Finally, the required reference substance whose Blaine value is closest to the cement to be tested. In this case, reference substance 1. All values are adopted. From the launch window, the newly created cement XYZ is selected for carrying out the test and compared with the appropriate reference substance, reference 1. A sample weight is submitted by the computer. The sample weight submitted by the computer of the required cement mass for the cement bed is prepared on the analytical balance. The tapered exterior of the measuring cell is lightly greased in order to guarantee that the U-tube is airtight. A sufficient quantity of the cement to be tested is placed in a bottle with a screw top. It must be shaken for at least 2 minutes to dissolve any agglomerates. The bottle is then left to stand for 2 minutes. Stir the cement with a clean, dry rod in order to evenly distribute the fine particles. The perforated disc is laid on the bottom of the measuring cell and lightly pressed with a rod. Insert a filter paper disc and lightly press it onto the perforated disc with a rod. The analytical balance is used to accurately weigh out the amount of cement calculated by the computer to 0.001 grams. Different working methods can be applied. Level the cement bed by lightly tapping the exterior wall. Apply another filter disc to the surface area and press it onto the surface with the rod. Guide the plunger into the measuring cell and carefully press it onto the powder bed to compact it. Press it so that the lower face is in contact with the upper edge of the cell. Now, Raise the plunger approximately 5 mm, rotate it through 90 degrees and press it once more onto the cement bed. Carefully withdraw the plunger from the cell. Should the plunger not reach the cement bed due to insufficient weight, a new calculation must be carried out with new suitable porosity. Return to menu item Tools, Manage Test Material and recalculate the sample weight by changing the value of the porosity. If the plunger collar doesn't reach the measuring cell edge because of too much weight, recalculate with a new porosity. Place the cell with a lightly greased exterior onto the glass cone of the U-tube. Enter the actual sample weight in the field. Click the Start button to begin the test, which will now run automatically. Flow time and temperature are measured electronically. First, the manometer liquid is sucked in above the upper light barrier. Then the pump switch is off. The first measurement of the first sample. The time starts on reaching the starting point. When the liquid level reaches the stopping point, the electronic time measurement stops, accurate to 0.2 seconds. The result of the Blaine test is displayed. Repeat testing of the first sample. The result of the second run. Remove the measuring cell. From below, the cement bed is pushed out of the cell. The cell is cleaned and prepared for the second cement sample. A first and second run on the second sample are performed. Afterwards, the mean value from all 4 measurements is compared with the Blaine value of the cement sample. The result is rounded off to the nearest 10 square centimeters per gram. Save the result. Choose Storage Location. Let us look at how the data can be imported into an Excel table. The spreadsheet can be formatted according to your preferences and accompanied in the header and footer with company address and date. Alkalis are released when mixing cement and water. Immediately remove any wet or dry cement which comes into contact with the skin. If cement gets into your eyes, wash them thoroughly with clean water and seek medical attention immediately. Protective clothing, rubber gloves and glasses should be worn. The tightness of the Blaine device can be checked by means of a rubber plug. If the device has to be shipped, repaired or disposed of, the manometer liquid must be sucked out with a syringe. Do not tip it out, as the electronics can be destroyed in the process. Close with a protective plug when not in use. The device may be returned to the manufacturer for repairs.